In the last class, we started with one problem. Okay, so simple problem. Let me discuss that with you. Can you read this problem for me?
Okay, a solution of A and B with 30 mole percent A is in equilibrium with its vapor which contains 40 mole percent B. Assuming that the solution and the vapor behave ideally, calculate the ratio of vapor pressure of pure A and pure B.
Right. So the first thing is that they have given me one information that a solution of A and B with 30 mole percentage, A is in equilibrium, right? It is in equilibrium. Okay, that means we have a solution of A which has 30 mole percentage as this concentration. Then it is in equilibrium with its vapor. It contains 40 mole percentage of B. It contains 40 mole percentage of B. Okay, that means we have 40 mole percent which is in vapor phase, 40 mole percentage which is in vapor phase of what? B. Now, if I look at the solution, 30 mole percentage of A, that means 70 mole percentage of B, yes or no? Correct? If you have 30 mole percentage of A, that means 70 will be for B, yes or no?
Yes, sir.
Right? Similarly, for vapor also we can write 60 mole percentage of A and 40 mole percent of B, which is given. Yeah. So
Yes.
40 mole percentage of B is given, 60 mole percent of A. Now, if we have 30 mole percentage of A, that will give me mole fraction of A will be equal to 3. That is the number of moles. Number of moles of A will be 3 mole, B will be 7 mole, 30% 70 है ना, 30-70 का ratio है. So we have mole fraction which is equal to 3 upon 7 plus 3, which will be equal to 0.3, and the mole fraction of B will be equal to 0.7. You got this till here, yes or no?
Yes, sir. Yes, sir.
Okay, then we have the vapor pressure. For that also, the mole fraction, YE here, it represents the mole fraction. It will be equal to 0.6 and it will be equal to 0.4. सही है?
Yes.
Okay, now moving on, we have the PA, which is according to Rawls law, it is PA, which is equal to the mole fraction into P total. This is according to Dalton's law. Okay, and we have again PB, which is equal to mole fraction into P total, which is again equal to Dalton's law. Okay, states of matter, 11th class, right? And
Yes.
you can also see why it is that. So YA will be equal to what? PA upon P total.
A by P total.
है ना? P total. So PA is in RT upon V, right?
Yes.
And number of moles of A, PV is equal to nRT, so we have got that, and P total will be equal to N total RT upon V, correct?
Yes.
And if we cancel RT upon V, what we will get? We will get Na upon
Na upon N.
N total, correct?
Yes.
Here we had P total, so we N total. This is what? Mole fraction only, na? Number of moles upon total moles, right?
Yes.
This is Dalton's law of partial pressure. Now, according to Rawls law, what is there? According to Rawls law, PA will be equal to P naught A chi A, PB will be equal to P naught B chi B, correct?
Yes.
Yes or no? Then we divide both of these things. We will get P naught A chi A upon P naught B chi B is equal to YA into P total, which is will be divided by YB into P total. If I take the ratio, P naught A chi A upon P naught B chi B is equal to YA P total, YB P total. P total will cancel out each other. Then we'll say P naught upon P naught B will be equal to what? Will be equal to YA upon YB. Then this will go here, chi A will come here, and you will get YA into chi B, YB into chi A, and then you can solve this again. So if you redo this question, then it will be better for you. You will understand it more clearly. And the ratio that we will get is 3.5. Okay, you redo this question when you get time after the class. Then we did types of non-ideal solution. So for non-ideal solution, we know that P total, it is not equal to P naught A chi A plus P naught B chi B. Now there can be two cases if that is not equal. The two cases will be the P total can be greater or the P total can be lower, right? It can be greater than P naught A chi A or it can be less than P naught A chi A. Achha. Now when P total is more, that means the vapor pressure is more, yes or no?
Yes, sir.
If vapor pressure is more, that means we have more number of vapors, correct?
Yes, sir.
And that means the gases, they are escaping easily. And intermolecular forces of attraction is decreasing, correct?
Yes, sir.
Okay. The opposite will be the case if we have P total which is less than P naught A chi A and P naught B chi B. Vapor pressure is more, है ना?
Yes.
Vapor pressure will be less. Yep, sorry, this arrow should be down. Vapor pressure is less. That means we have less number of vapors and it is not escaping easily. If we have less number of vapors, that means gases are not escaping easily. And if they are not escaping easily, that means we have higher intermolecular forces of attraction. Got it? Next is now this, if P total is greater, then it is known as positive deviation. So we'll discuss that first, positive deviation. है ना? In that, we will look an example. This example is important. You have to remember this example. Okay, ethanol plus cyclohexane. Now, in ethanol, what is the intermolecular force of attraction? It is hydrogen bonding. And in cyclohexane, it is London forces. Okay, it is London forces. Now, when we are mixing this, what is going to happen? Now, listen carefully. Let us suppose here we have ethanol. Okay, so all the ethanol molecules will have hydrogen bonding. Yes or no?
Yes, sir.
Okay. And what will happen if I add cyclohexane? If I add cyclohexane, it will occupy some space, correct?
Yes, sir.
But it can occupy space between ethanol molecules, right?
Yes.
Okay. Now, if it is occupying space between ethanol molecules, that means the hydrogen bonding in ethanol molecule, it will be disturbed because it is coming in between two ethanol molecules, right?
Yes.
And that is why the intermolecular force of attraction will decrease. Now, the force of attraction between the molecules inside the solution is decreased. That means they can escape easily, correct?
Yes.
Right. When they escape easily, the vapor is more, there are more number of vapors, and the vapor pressure also increases, right?
Yes.
Okay, so you understood this point? How
Yes.
ethanol and cyclohexane will give positive deviation. And this is only the thing that we have explained right now. After mixing, the extent of hydrogen bonding decreases, which leads to more vapor and higher vapor pressure. And these are the points. P total will be greater than P naught A Ia plus P naught B Chi B. Now, when we have, now look here, what is happening? The intermolecular force of attraction is decreasing, right?
Yes.
That means the molecules will be far apart, right?
Yes.
If the molecules are far apart, the volume will increase. Yes or no?
Yes.
Right. So V final, that means V after mixing will be greater than V initial. Greater than the previous one. Delta V will be equal to greater than 0. That is positive. Now, enthalpy of mixing. Enthalpy of mixing. Now listen here. We have AA and we have BB. Right. Then we mix it. We get AB and AB. Correct?
Yes, sir.
After mixing. In order to go from here to there, we will have to break these two bonds. Correct?
Yes, sir.
And then we will have to form these two. Correct?
Yes.
In order to break, we need some energy, and when we are forming, some energy will be released. Yes or no?
Yes, sir.
Now, when this particular hydrogen bonding breaks, we will be putting in energy, and that energy will be dependent on the magnitude of intermolecular forces of attraction. If the force of attraction is higher, more and more energy will be required. Now, when we are forming this, it will also depend on intermolecular force of attraction. If the intermolecular force of attraction is higher, we will release more energy will be released. But intermolecular force of attraction is decreasing. That means the amount of energy which is released is less than the amount of energy required to break the bond. If the amount of energy that is required to break the bond is more, that means we need to give energy in order to form the solution. If you are giving energy, then it is endothermic, and the delta H value should be positive. Got my point? Yes or no? Okay. Now listen here. Graph for positive deviation. It is very easy. Now, all the straight line, it is representing the ideal case, right? It is representing the ideal case. And the curved line is what? It is a bit higher than ideal. And that is why it is for positive deviation. In positive deviation, what happens? The P total is higher than P naught A Chi A plus P naught B Chi B. Similarly, this PA and PB will also be higher than the ideal case. You got my point? Yes or no?
Yes.
Yes. Okay.
Yes.
Now, moving on, negative deviation from Rawls' law. Now, you want to say something?
No, sir, no.
Okay. Now, in negative deviation from Rawls' law, here we have two molecules, acetone and chloroform. Okay, acetone and chloroform. Now, in acetone, we have polar bond C and O. O is delta negative, carbon will be delta positive, right? That is why this molecule will be polar, and the force of attraction will be dipole-dipole interaction, individually speaking, for acetone. Then we look at chloroform. So chloroform has 3 chlorine atoms, and these 3 chlorine atoms are pulling the electron cloud, right? These 3 atoms are pulling the electron cloud. Now, when these 3 chlorine atoms are pulling the electron cloud, what has happened? This carbon will also get delta positive, right? Because electron has been pulled. Now, this carbon, which is delta positive, it will be pulling more and more electron from hydrogen, because carbon is delta positive. Positive means it can pull electron, right? So electrons will be pulled towards carbon atom, and this will make this hydrogen a very delta positive, and that is why you will see a dipole moment in this direction like this. All this will be having delta negative because of chlorine is higher electronegativity, and you will be getting this type of dipole moment. Now, chloroform is also polar, acetone is also polar. But when I mix these two things, then I will see that since this delta positive in hydrogen is very high, and oxygen it has lone pair electrons, right? And this is negative charge, delta negative charge. They will form hydrogen bonding after mixing. You got my point, yes or no?
Yes, sir.
है ना? But please remember, acetone okay, so this is acetone, two molecules of acetone. This will not form hydrogen bonding. This hydrogen now of
Yes.
acetone, and why? Because this hydrogen is not having delta negative charge. It is not having higher delta negative charge. See, it is bonded to carbon. Carbon is further bonded to carbon only. Then it is further bonded to only one oxygen. But if you look at this hydrogen is so unfortunate. It is bonded to one carbon. He was happy. But this carbon is now bonded to 3 chlorine atoms, which is very electronegative, and it is pulling the electron cloud. Right? That is why this hydrogen is having a high delta positive charge. And a high delta positive charge, and oxygen which is having high delta negative charge, this will be almost like this will be very high dipole moment, and that is why it is considered as hydrogen bonding. So what is happening to the intermolecular force of attraction? If I look at intermolecular force of attraction, polar will have dipole, polar will have dipole moment. This polar will also have dipole moment. But after mixing, we will be getting hydrogen bonding, right? That means intermolecular force of attraction is
Increases.
increasing, right? It is increasing. Now, if the intermolecular force of attraction is increasing, that means the molecules will be escaping in a lower magnitude, yes or no? They will be
Yes.
not escaping easily. If they're not escaping easily, vapor pressure will be lower. Hai na? If they're not escaping easily, vapor pressure will be lower. Sorry?
No, no.
You said something?
No, sir.
कुछ तो कहा था आपने, क्या कहा था? Vapor pressure will be lower, right?
Yes.
And
No.
negative deviation. Low. Acha, you were saying low. Okay.
Yes.
So now hydrogen bonding is formed between. Now this is the explanation that we have just said. Now when we have P total less than P naught take IA, that means PA will be also less than P naught take IA, and PP will also be less than P naught take IB. When we look at V final and V initial, then here we see that V final will be lower than V initial because the intermolecular forces of attraction has increased, right? Intermolecular force of attraction has increased. When the intermolecular force of attraction increases, then the molecules will be occupying less and less space. That is why the volume is lower. The distance will be lower, the volume will be lower. So delta V will be equal to negative. Delta V is less than 0. Now when we are mixing, then what is higher intermolecular force of attraction is increasing. If it is increasing, that means we will be releasing more and more energy. If we are releasing energy, that means it will be exothermic. Delta H of mixing will be less than 0. That is delta H of mixing will be negative. Got my point, yes or no?
Yes.
Okay. Furthermore, the graph. Now in graph, what will happen? P total will always be lower than the ideal case. Hai na? So for the P total, PA and PB, all of these three plots, it will be lower than the ideal case, that is straight lines. Okay.
Yes.
Now we're doing some questions here. Now we will look at a few. So if you look at these two questions, which of the following liquid pair shows positive deviation? Which of the following shows positive deviation? Positive deviation means P total is greater. If P total is greater, that means vapor pressure is higher. If vapor pressure is higher, that means intermolecular force of attraction should be lower. So this is the point that we will be looking at. Okay. So this is the point that we'll be looking at. Now, if you look here, water and nitric acid. Water and nitric acid. So water is also having hydrogen bonding. Nitric acid will also have hydrogen bonding. So intermolecular forces of attraction is definitely not going lower. If I look at benzene and methanol, now this benzene and methanol. Now benzene is what? It is non-polar.
Yes.
And in methanol, it will have CH3OH. Methanol में क्या होगा? Hydrogen bonding होगा because of this OH.
Yes.
Right. So
Yes.
methanol is having hydrogen bond. If methanol is having hydrogen bond, that means what? It means that if I add benzene to methanol, then what the benzene will be doing? It will be hindering the hydrogen bond formation, and that will lead to the lowering of intermolecular forces of attraction. Okay, so the second answer will be correct one. Got a point?
Yes.
Okay. Now, similarly here also. Now, in generally what you will see, they will be asking you examples for from positive deviation only. Okay. And here you can see also benzene, non-polar, toluene, non-polar. Acetone is what? Acetone is going to be polar. Chloroform will be polar. Now both of these are polar. Chloroethane, polar. Bromoethane, polar. So as you can see, there is not a very large difference in intermolecular force of attraction. You will get positive deviation only if you have a very large difference in IMF. Okay. And see here it is what non-polar, non-polar, polar, 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 polar. But if you see here, this is what hydrogen bond, and this is what this is polar.
Polar. Yes.
Right. So obviously the hydrogen bond will be disturbed if I add something which is polar. If I add something which is polar, and that is why ethanol will be the right one here. Got my point? Yes or no?
Yes, sir.
There should be a large difference. Okay. Check. Let us move on to the topic which is this. Okay. Azeotrope. Do you know what is azeotrope from
No.
school? No. Okay. Okay. You know about distillation?
Distillation.
You haven't heard of distillation?
I have, but I forgot.
You have heard, but you forgot.
Yes.
Okay. So in distillation, what happens? We have a mixture, right? Yes or no?
Yes, sir.
If you remember something like this is there, and what we are doing, we are going to heat it, right?
Yes. Heating.
Heating is done, and then it will go above. There will be a pipe like that. It will get cooled, condensation will happen here, right?
Yes.
It will further go down, and then it will be collected in some flasks like this. Okay, it will be connected. There will be some cork here, and we will also have a temperature measuring thing, which is thermometer. You remember this now?
Yes, sir. Yes, sir. The action of purifying a liquid by means of heating and cooling.
Correct. Okay. Now we have two liquids, A and liquid B. Let us suppose the liquid A boils at 100 degrees Celsius. Liquid B boils at 200 degrees Celsius. Okay. Now, when we start heating, so at room temperature, it will be around 25 to 30 degrees Celsius. So we started heating. Okay. So when we started heating, the temperature, it started to increase. It was
Yes.
30 degree, 40 degree, 50 degree, 60 degree, 70 degree, 80 degree, 90 degree. It reached 100 degrees Celsius. Now at 100 degrees Celsius, what will happen? A will start to boil. Yes or no?
Yes, sir.
A will start to boil. Okay. A will start to boil. Now when A is boiling, what is happening? When A is boiling, what is going to happen? The temperature will be constant. Why? Because of latent heat of vaporization. Now, whenever something is boiling, the extra heat is consumed in order to change the phase of water to vapor, change the phase of liquid to vapor, and not to increase the temperature. So whatever heat we are putting it is consumed, and it is used to convert water to vapor, liquid A to its vapor. You got my point?
Yes, sir.
So now temperature is not increasing. Yes or no?
Yes.
Okay, now temperature is not increasing. Water, I mean, if let us suppose that A is water only, 100 degrees Celsius, and water is boiling. Water is boiling, temperature is not increasing, temperature is not increasing, not increasing. After 3-4 minutes, what do you see? You see that the temperature starts to increase. From 100 degrees Celsius, it went to 110, 120, 130. That means all the water has been boiled off, correct?
Yes.
There is no more water in the container, and that is how you have done the purification. Got my point?
Yes, sir. Yes.
So you can see that distillation, what is the principle of distillation? It is based on the difference in boiling point. Yes or no?
Yes.
If we had two different liquid, this P liquid has a temperature 100 degrees Celsius. Q liquid has a temperature, let us say 105 degrees Celsius. Now the separation of these two will be very much tough using distillation. Why? Because both of these temperature are what? These are comparable temperature. Yes or no?
Yes, sir.
When P is boiling, that means at 100 degrees Celsius, P is boiling. And we can say that Q will not boil at 100 degrees Celsius, but a large amount of vapor will be formed of Q also at 100 degrees Celsius. Is that right?
Yes, sir.
है ना? There will be vapors formed of Q. It will not be boiling, but there will be vapors, है ना? And that is going to again what again? It is going to make the container or the liquid impure. That is why the basis of distillation is what? Difference in the boiling point. If there is a huge difference in boiling point, then the distillation can occur very easily. Now, let us look at this case where we had acetone and chloroform, if you remember. Okay, we had acetone and we had chloroform. Now, acetone will be polar, chloroform will be polar, right? Now, this acetone will have its own boiling point. Chloroform will have its own boiling point. But when I am going to mix these two things, what I am getting a hydrogen bond. Yes or no?
Yes, sir.
Now, this hydrogen bond will be there in the mixture only. Hydrogen bond is not there in acetone, neither it is there in chloroform, right? It is not even in chloroform, but the hydrogen bonding is present in solution. That means this solution will have a boiling point which will be completely different than that of acetone and chloroform. Yes or no?
Yes, sir.
And this boiling point will be higher. Why? Because having hydrogen bonding, which is having a higher intermolecular force of attraction, because attraction is greater, that means we'll be requiring more and more temperature in order to boil it. That is why what will happen, the boiling point of this particular solution will increase, and it will have a constant, or it will have only one boiling point. If you remember, whenever we want to purify something, there should be two boiling points of a particular solution, है ना? एक आपका एक solvent का, दूसरा liquid का. But here we have only one boiling point, है ना? And that is why these type of solution, these are known as azeotropes, which boil at constant temperature. Similarly, if I look at the example of ethanol and cyclohexane, then this is polar, this is hydrogen bond, this is non-polar, right? This is non-polar, this is hydrogen bond. When we are going to mix these two things, what is going to happen? Intermolecular force of attraction will decrease. If the intermolecular force of attraction is decreasing, that means it will be requiring less temperature to boil. Yes or no?
Yes, sir.
There will be more vapors. Okay, so these are two types of azeotrope. Okay, so those two types of azeotropes are maximum boiling, in which the boiling point is higher, minimum boiling point in which you have the boiling point which is lower. Mixture which has higher intermolecular force of attraction will have higher boiling point. That means it will show negative deviation from Raoult's law. Okay, it will show negative deviation from Raoult's law. It requires higher intermolecular force of attraction, right? Because it is maximum boiling point. It requires higher and higher temperature to boil. That means it is having high intermolecular force of attraction. If I look at minimum boiling azeotrope, then minimum boiling azeotrope requires lower temperature. If it requires lower temperature, that means the forces of attraction is not very high. The forces of attraction are also lower, and that is why the solution will show positive deviation from Raoult's law. You got my point? Yes or no?
Yes.
Okay. So these are the things that we have discussed in the last class. Acha. One more thing is that what is happening in your school exactly in this chapter?
We're actually in the ideal and non-ideal gas.
Okay, you're in ideal and non-ideal. Okay. Okay. So one more thing that I want to ask is, do you do any other class here right now?
No.
Sorry.
You are asking if I were there in the last year?
No. Are you doing any other classes at Learnivio? If yes, then what are the timing?
Physics.
Sorry. Physics. Okay.
I'm in physics class.
And?
No, physics and chemistry.
Physics and chemistry only. Okay, so what is the timing for your physics class?
It's at 6:30.
6:30?
Yes.
And what are the days?
Monday and yes.
Monday and Wednesday, right?
Yes.
Okay. And what was I going to say? Physics. Okay. So Saturday, Sunday, like, are you free or you do some other coaching anywhere else?
I'm free, sir.
Saturday, Sunday, you're free. Okay, fine. So Saturday is your holiday, school.
Yes, holiday, yes.
Sunday will be okay. Sunday will not have holiday, right?
No.
Okay. So okay, will it be possible, like, if you change the time to Saturday, Sunday at 4,
Yeah, that's fine. I can do it.
but Sunday 4 p.m. will be fine?
Sunday 4?
Huh?
No, sir.
No, Sunday 4 will not be fine. Okay.
Yeah.
Then okay then. So I think it will be okay if we keep you in this batch only. That is Tuesday, Thursday batch. Okay. That is
Okay.
Tuesday, Thursday batch, and we will start after Azeotropes. Okay.
Okay,
We'll
sir.
start Azeotropes. I think the message that I got was many people they are having examination. Do you also have examination in your
Yes,
school?
sir, I have next month on 14th.
Okay,
14th.
you have on 14th.
Yes.
Okay, fine. Okay. So 14th you will be so solution chapter will be there.
Yes, solution and chemistry, the third chapter.
Electrochemistry.
Yes, electrochemistry.
कंप्लीट इलेक्ट्रोकेमिस्ट्री तो नहीं पूछ सकते है ना? They won't ask complete electrochemistry. I think will
Actually, in Ramadan, they
some
started the first chapter, which was later omitted
deleted.
by the CBSE.
Correct.
So because of that, we were in delay.
Okay, not in daily, like it's fine only. Okay, solution and then electrochemistry. Okay. 14th na? ठीक है. So I think those people who started like haloalkane, haloarene, some school they start like that, organic chemistry. So those chapters are coming. So I think those are the chapters in which they are having this. And we were studying here